Hello and welcome back to the channel. In this episode, we'll actually start discussing how to implement and incorporate the hookups for the user interface and the placements for the board pieces onto the player's board. So let's get started. I'm going to go ahead and share my screen and let's dive into the actual code and the explanation. All right, let's have a quick look at what we have so far. If you recall from our previous episode, we already have constructed the UI. In this particular episode, we are going to discuss how we are going to integrate the code behind and the actual triggers for being able to utilize a specific option on the UI. And as you're selecting the option on the UI, you can visualize that specific board piece that you want to place onto the board based on its orientation, whether it's a horizontal orientation or a vertical orientation. Very cool. All right, so I'm going to go ahead and stop this and let's take a look at some of the changes. All right, so let's jump into the code. The couple of first changes that we have done is that we started creating proper classes for representing the actual board. So we have an abstract base class called board, where we have a parent transform and the actual prefab that's associated with representing the board units onto the board. And of course, the actual two-dimensional array that's going to store the data for the board itself internally. And then we have a helper function to clear out the board whenever we are going to reset the game. And there's an abstract function called create, which is going to be implemented by the classes that are going to inherit from the board. So basically what we have done is created a base class called board, and then we're going to have two classes that are inheriting from the board base class, one of them being the player's board and the other one being the AI's board. So let's take a look at the player board. The player board is inheriting from the board class, and then in the constructor, it's basically expecting a prefab. That prefab is going to be passed to it by the board manager, and then it may or may not have a parent transform. If it doesn't have a parent transform, by default, it's going to be set to null. But if we do pass a transform as a parent, then obviously it's going to take that into consideration. And whenever we instantiate and create a board, it's going to have a create the actual board unit as a child to that particular transform. So once we instantiate, we set the proper properties and we assign the proper properties to the variables. We clear the board and then we wait until the create function is called. And once we call the create function, this basically goes ahead and generates the board for this particular player. So nothing has changed as far as the actual creation of the board is concerned. What we have done is that we restructured and refactored how it's going to be done. That's going to be a little bit easier for us to manage into the future. Similarly, on the AI board, again, we have the AI board class. It's inheriting from the board class, and we do instantiate the prefab. This cube prefab is going to be utilized later. For right now, it's just a placeholder. And then we have a parent. And then basically we clear the board and we wait until the create function is called to again instantiate and generate the AI board as well. So those are a couple of changes that we have done on the board side. So again, on the game manager side, basically the way these guys are utilized is that once we instantiate the player board, we pass in the prefab associated with the board unit. And then in this particular case, we are also passing a transform where we want that particular board to be generated as a child. And then we invoke the create function and it goes ahead and does what it's supposed to do, generate the function, generate the board. The next big thing that we have done is incorporate a UI manager. So the UI manager is going to be responsible of handling the events that are coming from the UI and then messaging these events across the whole game, whoever's going to be listening to it. So we do have a couple of custom events that we have defined. One of them is on change the ship, on change the orientation, and on restarting the game. So we have implemented the change ship and change orientation features. The restart game feature has not been implemented yet, so we'll cover this later. Down here, we have a collection of buttons. The collection of buttons is going to be referring to all the buttons that are represented on the UI level for each one of the pieces. And then we have three distinct buttons, one for each one of these features or functions. One of them is for changing the orientation. One of them is to reset the actual game. And the other one is to exit the game in general. Finally, there's this dictionary definition, and this is going to be utilized as an internal way of representing the ship IDs and what each ship size is going to be. So this is going to be utilized later on by the board manager to identify which ship ID it's dealing with or it's placing onto the board, but more importantly, the actual size of that particular piece, which we are going to then later on visualize. And then over here, we just have two functions. One of them is going to be utilized to handle the on-click event for all of the board piece buttons, and it's expecting the ship ID that's going to be coming from the button itself. And basically, it checks to see if that particular ship ID is within the dictionary that we have defined. And if that's the case, we get the size. And if it's not, then obviously we get a -1 where we display a warning back to the user. And if the ship ID is valid, then what we are doing is that we are invoking our custom event on change ship, and we are passing in the ship ID and the size of the ship associated with that particular ship ID, where whoever's going to be listening to this event is gonna be able to like utilize them to perform their duties. Similarly, we have another function called bot change orientation, which is going to handle the on-click event of the orientation button. And basically, what we are doing is inverting the orientation state, and also we are passing that orientation to the on-change orientation event whenever this is raised. So let's go back to the designer so we kind of visualize how this is working, and then we'll go to the board manager to dive into the actual visualization of the board pieces. So let's click on play. So over here, by default, the board manager is going to be set to select ship, the patrol ship, which is ship ID 4, and it has size of 2. So basically, as the mouse is pointing onto the board, depending on the size of the ship and the orientation of the ship, which by default, again, is vertical, is going to go ahead and visualize how that particular piece is going to be placed onto the board. So if I change the orientation, notice that now it's on the horizontal, and if I change it again, it's on vertical. So if I go ahead and select the carrier, so the carrier is the largest piece, which has 5, basically it occupies 5 units. So this is the vertical version of it. And then if I change to the orientation to horizontal, this would be the horizontal. Notice also that as I get closer to the edges of the board, depending on the size of the ship, it's not going to draw it. So there's some boundary checkings as well. So as long as you're within bounds, then you should be fine. So let's go ahead and stop this now and jump back into the code, specifically the board manager. So the board manager is subscribing to those on change ship and on change orientation events. And basically we have these delegate functions where we set the internal ship ID and the ship size for the board manager based on the parameters that have been passed. Similarly, it's just inverting its orientation, vertical orientation. So even though we are passing in an orientation variable over here, we are just utilizing the internal vertical Boolean flag to invert it. We can very easily just set it to this orientation as well. In the update function, this is where we check to see if the player is supposed to place their pieces. And right now we are simulating this. So as long as we haven't placed any pieces, go ahead and execute this particular function, which indicates that go ahead and place the player pieces. And inside this function, what we are doing is that we are, again, using some raycasting as far as the mouse position is concerned. And most importantly is placing of the block over here. So this code over here is a placeholder. We'll talk about this later. But more importantly, let's talk about this placing of the block. So what happens here is that if we are okay to place a particular piece onto the board, we check to see which orientation we are at. We are either in horizontal or vertical. And based on that, we also check the boundaries as well, whether we can place that, like what are the dimensions that we need to worry about. And then, of course, we have a for loop that iterates over the size of the ship to construct the visualization of the blocks that you have seen based on the row and the column that the mouse is pointing to. These code blocks over here currently are not going to perform anything, but basically they check to see if that particular unit, board unit that we are instantiating and visualizing this particular board piece is going to be occupied or not. And if it's occupied, then basically we provide like a visual clue with a yellow tone as far as, okay, this place is occupied, you won't be able to place it here. And also we set the flag to false. Similarly, the same concept applies to the vertical orientation with its own boundaries. So based on the size of the ship, it generates all of the necessary visualization of the blocks and checks to see if each one of those unit boards have been occupied or not. And if they are occupied, then obviously we visualize that specific piece or section of the board or section of the piece to yellow, and then we mark the flag so that it's not okay to place it. Okay, so all of this is pretty much handling the visualization of the blocks that you see over here. Again, let's go ahead and run it one more time. So once the boards have been generated, if I go ahead and select each one of these pieces, notice that as I'm moving my mouse across the screen, it's visualizing the blocks. And let's assume that there was already a board piece occupying the space. You would see those squares, those cubes turn yellow. All right, very cool. Okay, so that's it for this episode, and I'm gonna go ahead and stop sharing the screen. All of this code is gonna be available for free. Make sure that you guys become a member on the Patreon site. So the description of how to get there is the link of how to get there is in the description. Go ahead and click on it. Become a member. The membership is free. As a member, you do get access to the code. You have to become a member to be able to get access to the code. So don't forget to subscribe to it. Again, it's a free tier. And once you become a member, you should be able to download all of the source code and the Unity packages associated with all of this training material that we have. All right, talk to you guys soon. See you guys soon. Bye bye.